Feezer Amplification, helping musicians to perform better. Welcome to Feezer Amplification here in California. My name is Eric. Today on the test bench we have a Sherwood S-7700 electron tube receiver. This amplifier was designed in the late 1950s, and the customer has brought this receiver in for general service. Let's begin. We are looking at the Sherwood S-7700. Looking at the front panel. The front panel has been polished and cleaned by me, and this is how I wanted to introduce the video. So I'm finding a lot of not so good things inside this Sherwood. Someone went in and used an old electrical cord here and then spliced in these power supply wires. Not great. I don't know why this person did this. Shame whoever did this. If you don't know how to work on amplifiers, don't work on amplifiers. This is dangerous and it's very bad. The customer was complaining that there was some kind of arcing when he was turning on the amplifier, so the person who serviced this or did this did something here. Or maybe the technician didn't do it, but he didn't repair this, and I doubt it's just for cost savings. This is not good, so very disappointed to see this. Okay, so we have properly repaired the two wires here, and we have shrink wrap. I've got double shrink wrap on these two and on these two as well. It's much better and much more safe. So we'll move on. I'm noticing that we're missing lots of screws on the chassis and things of that nature. I'll point that out as we move along. Alright, we're looking at the Sherwood S-7700. That's the model number. You can see here that we have a fairly dirty chassis. We're missing a lot of fasteners here. We're looking at 20 tubes total. The first row of preamp tubes have been tested. The output tubes under this heat shield has also been tested, and the phase inverter tubes have been tested. We'll test the rest. Again, this is a series of 20 tubes. Looking down here at the dial indicator, we have lubricated that with lithium grease, and we've also lubricated this wheel here, this mechanical wheel, with lithium grease. A little bit of lithium grease on the string. We will remove that. Lithium grease is very messy. You don't have to use lithium grease. You can use some other type of oil. That's fine. That's not a big deal. So this is what it looks like. It's not in great condition. We do need to clean the chassis a little bit. This is a biohazard, unfortunately, for those of you who are new to this. Maybe you're working on your own amplifier, maybe you inherited something or you picked something up on eBay. Please wear gloves. It's a biohazard because rodents tend to come in here, nest in here, urinate on everything, and that's probably not too healthy for you. So please be careful. But we'll clean this up and as best as we can. We're just trying to preserve this amplifier. We are not trying to restore it in any way. We're just trying to preserve. So let's go ahead and move on to the next segment where we can look at the underside chassis and take a view of the circuit board. Well, here we are looking at the circuit. The customer complained that there was some type of arcing during power up, a flash of something, and here's why. We're looking here at the first electrolytic capacitor, and it's just hanging off here. It's loose, and this is very dangerous, as this can touch the bottom plate and cause problems, cause arcing, cause shock. It's a shock hazard. Another electrolytic just here dangling. Lots and lots of electrical tape that I pulled off in this section. This is also dangling. A lot of current is going here. You can even see something happening here, this black color. I can't tell if this has been worked on by multiple technicians. I have a suspicion that this was done by somebody who is not a technician, who was just trying to repair their own amplifier. This is someone who's new, because we have all these different types of electrolytic branded electrolytic capacitors here, another one here, more stuff happening here, more loose things hanging off here. This is absolutely incorrect, improper way to do something like this. I'm thrilled to see that there is Solon capacitors that looks like these are the coupling from the phase inverter into the power supply tubes, the grids. And again, this just doesn't look so great. Now you may look at this and say, wow, this is really congested, but it's actually not too bad. But this is a problem. All of this, I'm not too sure what I'm supposed to do. Normally you would just replace the CAN capacitors. Manufacturers do make CAN capacitors that you can replace multi-section types. It's no problem. This person chose to do something else, and this is just absolutely all bad. It's just really bad. I don't see a thermistor here in this section. This is the rectifier section here. You've got the original diodes here. Unfortunately, this is a strange mess. I don't know, you technicians out there, what do you think I should do? If I replace all this with CAN capacitors, that's going to take a lot of hours, and we're going to have to charge our customer a lot of money. I know you're all thinking just put some silicone and sort of mount that down here. I don't want to use epoxy because we want to probably replace this sometime in the future. Maybe. I'm not sure what my customer wants to do. I'm going to try my best to make it safer. At the very least, maybe I will do the silicone adhesive just to keep things from rattling around and make sure that the cover doesn't touch anything that it's not supposed to touch. What a shame. It's a nice amplifier, and someone did this incorrectly. This is the first time I've ever worked on a Sherwood, and this is also the first time I've ever seen a former technician or owner or whoever did this do such a poor job. Most technicians come from the military, and I've seen lots and lots and lots of really nice military spec type repairs. This is the first time in 20 years that I've ever seen anything like this. I hear about stuff like this going on. I think there's stuff on YouTube, but this is my first experience, and I'm frustrated and disappointed. Lots and lots of electrical tape. We've got some shrink wrap. I don't know why there was such a weird mix here. I don't understand. I don't know what this means. Like, what is this? I just don't understand what happened here. This is just really awful. Yeah, I'm not too sure what to do here. I think I'm just going to well, I'm not sure. I have a suspicion this functions. I mean, look, we have a 1/4 watt resistors here coming off this tube. This should be a 1/2 watt. Yeah, I don't know what happened here, but this is a problem. This is probably why it's arcing and doing all these weird things. So again, if I restore this properly or repair this properly, although it's functioning, I'm confident it's functioning. It's going to be expensive. The parts are going to be expensive. It's going to take me a lot of hours to get in here and undo all of this, reroute the wiring properly. So anyway, I just thought I'd share that with you. What a shame. What a shame. So we'll see what I decide to do in the next segment. So let's move on. Alright, so here we are again looking at the circuit. You can see here in this section there's silicone, and so you can guess that I chose silicone to secure the electrolytic capacitors that were bouncing around inside this circuit. Using silicone to secure electrolytic capacitors are used in modern manufacturing. However, the electrolytic capacitors are mechanically secured to the circuit board in modern manufacturing. This is not. But this is a small solution to securing all these electrolytics, as opposed to just rebuilding this amplifier. I was looking at the S-7700 model schematic, and nothing seems to match up here. This doesn't look like anything in the schematic. Now, it doesn't necessarily mean that the former person who worked on this did something different. Maybe something changed, maybe a revision at the factory. They changed the way that the circuit was going to perform or function. So I'm just going to kind of secure all this and kind of walk away. Just going to secure it and walk away. Sine wave looks good, like I said, 1 kilohertz. This is not anything that I would have done. I don't even want to put my name on this. But I thought it would be interesting, at the very least at this point, to show you what the circuit looks like. Maybe this is helpful for another technician to see what this looks like, but this is not something that I did. This is something that somebody else did, and I'm just taking a look at why things were arcing around inside here. So I'll run a harder test in a little while, and I'll tell you what the results are. I'll show you the 1 kilohertz sine wave as well. And in the meantime, you know, I'll just do a general service that's cleaning the pots and input jacks, and at some point soon I will just hook this up to some speakers and just take a nice listen. It's using a circuit design that is known for a very three-dimensional sound. That's how most audiophiles describe it. I'm going to have that experience for the first time with this particular tube amplifier, as opposed to what I have in my own system, which is the H.H. Scott. And we can go over that at another video series. Alright, let's see what comes next. Alright, here are some reference voltages. Looking at pin 2, we have negative 18.87 volts. The high limit is negative 21 volts, so we are in spec here. Now moving on to pin 9, this is the plate voltage, and again, these are the output tubes. Looking at the output, we are looking at 441 volts. No, 440 volts at the plate. So we are in spec here as well. I believe the high limit is 450 volts. 450 volts is the high limit, so we are okay here as well. Here we can see that we have a strip screw here. So we'll have to drill this out. This secures the outside chassis to the amplifier. This section here. Drill this out. Not fun. Okay, we replaced all of the fasteners that were missing with new fasteners. Just wanted to highlight that. Alright. So we have everything buttoned up at this point. We have all of the fasteners replaced, all of the missing fasteners. We have the bottom plate fastened properly. We have deoxided all of the potentiometers and input jacks, switches as well. We have the outside enclosure assembled, and I'll show you a couple of shots of that in a moment. And now we're going to go through all of the functions. At this point, although it looks, I believe, a kind of a pinkish here on the video, but this is a bright orange, and this is auxiliary. Moving on to the tuner, and we're going to pay attention to this area here, the dial. And the light comes on, and this is really nice. We have a magic eye tube, and as we tune, you'll see the tube eye open and close. Of course, we have our stereo light as well. Moving on to the selector switch from auxiliary to tuner, and we have a nice bright green light. Tuner to phono, and then again tape head, from phono to tape head, and this is a nice pink color. We have our stereo light functioning properly, so this is very, very nice. I really like going back to the tuner. Both lamps are working properly. There are two on each side, and this magic eye is just delightful. I'm really pleased with this. We're going to take a look at the sine wave next on the oscilloscope. So let's move on to that part of this. Let's move on to that part of the video. As I noted before, I used lithium grease on the dial track, and it's really made a big difference. The tactileness of the dial is just really delightful, really nice, very balanced, not unlike what you would find on a 1970s Marantz. Really nice, really pleased here. Everything has been cleaned, the dial face, front and back, all of the front functions, chrome plating, all have been cleaned. We did not over polish this, we just want to preserve this receiver, and I think we did a good job here.